Very good morning, my dear friends. I welcome you all to my YouTube channel. Myself, Dr. M.H. Annaya. Friends, in this video, we are going to work out a problem on the projection of a rectangular pyramid whose dimensions of the base are 30 mm and 60 mm and the vertical height is 80 millimeter. That is the height from the center of the base to the vertex is the height that is given to be 80 mm. Let's see what the question is there for today's video. The base of a rectangular pyramid of dimensions so and so and height 80 mm while resting on one of its base edges on HP. So it is very obvious from this statement that the pyramid has to rest on HP to start with. It could be on a longer side on HP or on a shorter side on HP depending on what is to be obtained in the second view. So friends, first of all we should be very careful and decide how to place the object. Is it with the longer edge coming to the right side or with the shorter edge coming to the right side? So that is very, very important. And particularly, I have not given that intentionally. So, friends, suppose we are going to place this on HP with a longer edge perpendicular to VP. Then, friends, what happens? If you rotate like this, the two longer edges, that is 60 millimeter side, remain unchanged, whereas the shorter side, which is 30 mm, that keeps on decreasing, and whatever the inclination you make, the base of the solid, which is a rectangle, will never become a square in the top view. So this is very important. So what is the other alternative left? That is, you have to place the object on one such that on HP on its base, such that one of the shorter edge, that is 30 millimeter side, is to your right side. So that when you tilt this object like this, friends, these two shorter edges, since they are perpendicular to the VP, they remain the same, whereas the longer dimension gets reduced. So there is one particular inclination of the base with the HP or the axis with the HP for which this millimeter, that is 60 millimeter side, appears as 30 mm. So friends, you have to place the object initially on HP such that one of the shorter edges of the base is normal to VP and obtain the top view, a rectangle with longer side parallel to VP and the front view, a triangle which is isosceles in nature. So friends, we will mark this XY line, mark VP and HP to indicate the first angle projection. Now friends, I am going to write the top view of the solid, that is a rectangle of dimension 30 millimeter by 60 millimeter. So friends, this we will take it as 30, the shorter edge, and I have given you very clearly why it should be placed like this. And this as the dimension, the longer side has a dimension of 60 millimeter. Friends, for all the pyramids you know very well, the corners of the opposite side are to be joined to the center. So this is one diagonal, this is the second diagonal, and friends, you have this top view. We will call the vertex, there is O comma O1. O is the vertex, O1 is the center of the base. And we are going to mark the corners of this pyramid, the base of the pyramid, as A, B, C, and D. Friends, we will draw vertical lines from these points and obtain the front view of the solid. The height of the solid is being given. The height is 80 mm. So you can mark this at 80 mm. Excuse. I join this O dash to these corners, that is A, B, C and D. This is with A and B, this is with C and D, this is O1. The axis of the solid is perpendicular to HP, and these points are A dash, B dash, C dash, D dash, and O is the center. Friends, this is how the pyramid looks in the top and front views. Next, friends, he says the base of the pyramid, rectangular pyramid, appears as a square in the top view. Now, friends, it is placed like this. We have got the front view, we have got the top view, we have joined the O, the vertex to all the corners. Now, it is tilted on this edge CD such that the base appears as a square in the top view. Square. And they have not even specified what is the size of that square. And it is very obvious from this, the shorter side will have the square. That is, the dimension of the square will be the shorter dimension of the base. So friends, adjacent to this figure, I am going to draw a square of the given side. Side is, I told you, it should be only 20, that is 30 by 30. It is a square. So I'll write down here 30 s cube, indicating that it is a square of 30 millimeter side. And friends, here I'll just mark this as A, B, C, D. And friends, this when you rotate, CD will rest on the HP. When you tilt it to the right side, CD rests on HP like this. I am going to redraw this. So this CD, position of CD is fixed. That is, C dash D dash should be on this line. And friends, through this point A, I write a vertical line. And friends, remember, this is figure number 1. The figure number 2, what we are going to draw, is going to be a photocopy of this. That is, this is to be placed like this. And friends, whatever the base you have got, that is when rotated, appears to have the same dimension. So friends, I will take C dash D dash as center and this 60 millimeter as radius. I draw an arc to cut the vertical line drawn through A at this point, and friends, I am going to join that to this, and this A dash B dash will move up. Now friends, we can mark the center of this. Center of this I have marked. You know the radius or the height of this. I am going to mark this point here. And this is going to be the new front view that is obtained by projecting the points from here. And friends, this is the top view you have got. Before that, let me mark this vertex O also to add in the top view. Friends, now this is the vertex O. I am going to join O to D, O to C, and OA and OB are visible when you see from the top, and hence I am going to mark a visible line for OA, a visible line for OB. Friends, you can observe here this corner CD, not CD, that is the base at CD, is on HP, and when you see from the top it is not visible, and hence I have to show this by a dotted line. So this edge is not visible. So we will mark O1 dash, the center of the square. So this is O1. O1 is the axis of the solid, and the HCD on which it is resting is not visible. Friends, let's see if it is possible to measure any of these parameters. It's been asked to determine the inclination of the axis with HP. O dash, O1 dash is the axis, and if you measure this angle, say this angle is theta, this is the inclination of the surface or inclination of the axis with the HP that can be measured. The distance of the highest edge from HP. Friends, this CD is one of the edges of the pyramid, and this is A dash B dash is the other edge. So you will have to find out what is the height of this edge AB from this horizontal. So they can keep a scale and find out the inclination of the base with HP. See friends, the base is this line A dash, B dash, C dash, D dash, and this is the base. This angle theta we know, the axis and the base are perpendicular to each other. So the total angle here, suppose I call it as say some phi. So theta plus phi plus 90. Theta plus phi plus 90 is equal to 180 degrees, or theta plus phi is equal to 90 degree. Means what? If this is say some 45 degree, this will be 90 minus 45. If it is 60, this will be 30. And hence, you will be able to find out all these parameters asked in the question. Next friends, let us see what else is asked. Draw the projections when the edge on HP is inclined at 30 degrees to VP. Friends, the edge of the pyramid resting on HP is this CD. That CD is resting on CD. But now that CD is perpendicular to VP. I will write down here CD perpendicular to VP. But friends, it should be at an angle of how much? 30 degrees to VP. Friends, I am going to redraw this figure. Say figure number 3 as figure number 4 with CD inclined at an angle of how much? 30 degrees to VP. So friends, I will write a line here anywhere on the x-axis, and there I am going to mark say this AB and R. You can keep it any way you like. So I will just construct this figure. Same figure here. This is going to be 40. You know very well. This is 40, and this line CD is this line, and then you can mark the center of that. I'm just reproducing this figure. Oh, this is the point, not so much. This point is O, then CD comes here, which is a dotted line. Same figure is reproduced, and I'm going to join this here. So this is going to be CD. So this is, I will mark it as A, B, C, and D. This figure and this figure are exactly identical, and we have at the center the point O1. This is O, the vertex. AB is one of the edges. Friends, since AB and CD are parallel to each other, if AB is making an angle of 30 degrees with the VP, CD will also make the same angle. Friends, now we have to join this O to B, then O to A. We have got all this. So figure number 3 and 4 are the same. And this figure will give you the top view of the pyramid. Friends, now let's obtain the front view corresponding to this top view. Friends, we will start with this A, B, C, D, etc. So friends, A and B should lie on this line. So I will write a horizontal line through A dash and B dash. Vertical lines through this A and B, and obtain the points A dash and B dash. So this is A dash, friends. This point is B dash. Friends, C and D, they are on XY. So horizontal from C, vertical from C will give you this point C. So just show upward because you're drawing lines from this. This point is going to be C dash. Just mark below. This is C dash. Similarly, D friends, D is here at equal distance from there. You get this point D. So this point is going to be point D. Little closer here. This is point D. That is D dash, A dash, B dash, C dash, and D dash. Friends, we have got this O here. Write a vertical line through O, a horizontal line through O dash. The point of intersection will give you O dash. Friends, you can just join all these now. So I am going to join B dash to C dash, O dash to B dash, O dash to A dash, D dash, sorry. And then we have this D dash to C dash. And friends, this A is not visible. So, but now we are joining O to C. O to C is visible to the observer. So show by a full line. And what is not visible is this point A dash, and all other lines connecting that are not visible. Hence I am going to show this by a dotted line and another parallel line through this by a dotted line. We'll mark the center of the base by drawing lines like this. Friends, this is our point O1 dash. That is the center of the base. Friends, this is how the pyramid looks in the front view when the edge on which it is resting, that is CD, is at an angle to VP. Friends, I hope the presentation was interesting. Please go through the complete video. If you like this video, please share the information with all your friends without fear. And in case you have not subscribed to my channel, and if you like to subscribe to my channel, please do it today without fail. Have a wonderful day.